Hello, good morning. Thank you for joining us. My name is David. This is Alec. Today we've got a very exciting subject to share with you guys. We know that we have a large range of products of diverse technologies, and that very much suits us in being able to pick the right specification for the right application. But customers will very often ask us, where do we start? What particular part of the range should we be looking at? And today we intend to address that, Alec.
Yeah, really looking forward to this. It's going to be an interesting presentation. This is very much free-for-all, so bear with us. We could go in any direction. But as always, it is going to be an interactive event, so we encourage you to participate and bring us your questions. So at the end of the session, we'll open up for some questions, and David and I will do our very best to try and answer them.
We will indeed. Right, let's get down to the business in hand then. Let's look at those main application drivers that customers need to be considering as a pointer to the different ranges that we have and is right for their particular application needs.
Yeah, so really this is the point at which David or myself or one of our colleagues would come and see you. And you may well be at the very start of your design. You've been tasked with looking at a particular challenge to overcome, whether it's a production line, and typically you'll be taking a product or an item and moving it from point A to point B. That's the fundamental challenges that we deal with, isn't it, David? And there are specific application parameters that we need to know as engineers to help you specify the right solution for your application. So yeah, to kick this off, I mean, I guess the first question I would ask is surrounding payload. It's a very key question, how big is the mass you're moving, both in terms of size of its weight and its size.
We definitely need to expand on that further at a later point. In addition to the payload, it's the position of the payload, what that payload looks like in relation to the slide or to the linear system that it's moving within. And the payload will dictate sometimes the design of the linear system. So again, two very important factors to start with.
Yeah, and probably one of the next one on the list, which is very important to you, the customer, more often than not, is the throughput. Okay, so your machine will be designed to perform a certain throughput, and this is particularly relevant to production machines. We see it, 50, 100, 200 parts per minute, and it may be that you are tasked with reaching a certain level, or maybe you're replacing an existing system. And you need to increase your throughput, maybe double it in some instances.
Absolutely right. One of the ways of increasing your throughput is to increase speed. The speed of the system relates to the speed of the linear movement, and that does manifest itself on the choices of linear or linear technology that are used.
Yeah, and equally, going hand in hand with speed, you've got acceleration.
Arguably more important.
All part of the motion profile, and that acceleration can have effects on the overall slide system, guidance system, because of the reaction forces it can potentially generate.
No, quite so. The next one is stroke in terms of length of travel. It's not just what you're moving, it's how far do you need to move it. And we've spoken about speed of how to move it. These are fundamentally important factors in the decision-making process, and we'll certainly be touching on that in a minute as well.
Yeah, and the next one that's often very relevant to you as designers, and selling these machines in the first place is the space envelope. It can dramatically affect the footprint of your machine, and the smaller you can make your machine, the more machines you can get in a single factory.
Quite so.
So the packaging of the overall guide system is very important in these situations.
After that, I'd follow that up with installation. In terms of installation, certain types of linear technology will be easier to install, and it could be a factor in terms of where that linear technology is in the overall machine. If accessibility is easy or difficult, and we'll certainly be touching on that.
Yeah, and the next question we would sort of put to you is what sort of accuracy or precision do you require with your slide system? Now, if it's a application, you know, putting the cherry on the top of a Bakewell tart, you're not going to worry too much about the position of that cherry, you know. Plus or minus a couple of millimetres, it should be good enough.
Well, okay, I do like it in the middle.
But you know, perhaps if this was a circuit board and you're installing microchips onto that circuit board, then certainly you need to be sub-millimetre accuracy in those instances, you know, very sort of small fractions of a millimetre.
Yeah, that's a good point. Next is environment. I think we could have a whole session on the environment. It is important. It does. Certain environments are critical to the type of linear technology that's used. We've discussed this many times before, and we'll cover some of those elements later on as well.
Yeah, and environment is an external factor, and there are other external factors we have to consider as well, which are things like sort of press forces, vibrations and things like that, which can also be transferred through the guide system, and it needs to be able to cope with that.
Yeah, okay. Finally, I'd say maintenance is a key factor. In some situations, a reduced maintenance program is a cost-effective solution and is often desired, and less maintenance means less machine downtime and higher productivity that you touched on in the first place. So again, maybe not something that's considered every time at the start of the process, but we try to include that in our thinking.
Yeah, absolutely. And then overall, at the end of it all, you've got to consider what's the service life of that system. You know, how long do you need that system to run for before you effectively have to do either considerable maintenance or throw it away and replace it? And then going on from that, you've got your sort of overall return of investment, David. You know, all of these machine designs that you're putting in place, you've got to consider all of the costs that go into designing, installing, running, and then replacing that system through its entire life cycle.
It's quite so. It goes far beyond the initial cost of the parts. You've already said it. We need to expand on that further, but yeah, it's a very important factor. Can we start, Alec? We talked about the fact that within our range we have various types of linear technology, and we know one type that is very much suited to a broad band of applications with certain features. But can you give us a summary of what those different linear technologies are, please?
Yeah, so I've got to start at the top with the V-Guide system, because that is effectively our core product. Yeah. And there's a good reason for that, and I think you'll agree with me that the V-Guide really offers the most broad sort of viability for most applications. I think it's very flexible in terms of the wide array of applications it can cover. But that says it's not a one-size-fits-all solution.
It's true.
And there are instances where you might want to consider other technologies, and we'll sort of look at some of those today. And in particular, you've got sort of recirculating ball technology, which is sort of ball guides and your shaft-based recirculating ball bushings. Also within the shaft-based range, you have plane bushings as well, which have particular advantages in certain applications. And then going on from that, you've got sort of niche type of solutions such as telescopic guides.
Yeah, quite so. I think what we're going to do today is try best to unravel certain niche scenarios where maybe some of those other technologies other than the V system might be better suited or might be suited at a certain time. Okay, I think for me, we'll get on to, where do we start? We're going to go back to payload in a minute, but just as a brief overview, we have our core products. We have, based around the V system, GV3, which is about straight lines, and PRT2, which is about curves and track systems and so forth. And then outside of that, we have heavy-duty versions of both in the form of HDS2 and HDRT, and beyond that we have driven systems. So to maybe the first place to start is how much the customer is looking for a complete solution, how much design they would like to do themselves, how much of the assembly work they would like to do themselves, and how much they would like Hepco to assist them with that. Okay, and that's a different subject that we can touch on. But let's get back to that payload thing then. Okay, the first thing we ask a customer is, okay, what are you moving? What is it? What's the size of it? What's the physical size of it? And what does that mean in terms of mass?
Yeah, and the reason that's our first question that we put to you, the customer, is because that is extremely fundamental to the solution we'll be looking at. So, if the payload's only 2 or 3 kilograms and, a couple of 100 millimeters across, then, we instantly know that needs to be at the sort of smaller end of the scale in terms of the guide systems. And we're not looking at particular technologies yet. We've not got that far, but at least we know which sort of size range to aim at. Yeah, if it's several hundred kilograms, or even going up into tons, then we know that we need to be looking at one of our heavier duty options.
Yes.
And, that could be heavy duty, it could be ball rails, it could even be a channel type guide. But, again, there's lots of other questions that you have to tick off before you can funnel down further. But fundamentally, the payload allows us to home in on what approximate size of guide system we need to use.
Yeah, quite so. So immediately, if I'm thinking about a carbon steel system and somebody says to me 10 kilogram payload, I'm immediately thinking GV3. If somebody says to me it's a 1,000 kilogram payload, I'm immediately thinking heavy duty, HDS2. But we also know that there's a big overlap in maybe a smaller payload but with a bigger offset compared to a bigger payload but maybe directly situated over the slide or slides, and that can also have a deciding factor as to what ranges are being used. And customers, to a large extent, have flexibility to choose the range that they would like to use.
Yeah, and you make a good point there about the offset load. Moment loads are quite critical in terms of determining which solution. Now, in terms of, and coming into this is also sort of installation challenges that you might face.
Right.
If you can run a single rail, the installation is very much more simple.
Yes.
Okay. But if you've got a high offset load, then that single rail needs to grow quite considerably to cope with it. Now, if that size of that rail is prohibitive, what you need to then look at is potentially using 2 smaller rails, but run them in parallel. Okay, and that gives you a much greater moment capacity because you're spreading the distance between the bearings. But then you add in some extra complications because of the installation. You're now trying to align 2 rails in parallel.
Yeah, 2 elements rather than one. Yeah.
What's the best solution in that situation? If you're trying to align 2 ball rails in parallel, you need to do a lot of prep work. Those surfaces need to be machined and they need to be absolutely spot on parallel. Otherwise they start fighting against each other. You preload the system, it's more driving force, it's more wear. So in that instance, you might think, okay, how can I make my installation easier? And by running perhaps a V-guide on one side and a flat track opposite, you build in some compliance into the system. You've still got that moment capacity, but you're taking away the pain point of trying to align two guides.
Absolutely so, and this ties in with speed, with stroke size and speed, which we'll get to. But a lot of modern systems, a lot of modern process lines are these days in certain industries are a lot longer than they used to be. We're looking at systems these days in excess of 50, 80, 100 meters long. And that's a lot of travel for a type of rail that demands complete alignment and complete accuracy, especially when you're aligning two in parallel. Whereas with the V system in that sort of instance, not only have you got more compliance if you were running two Vs in parallel, but keeping everything sort of like aligned over meters and let's just say 100 meters. That's a long way to keep everything aligned. That's a lot of cost, a lot of time to align those elements perfectly and keep them aligned. And that we know that with a V system, we can use a V system on one side. And again, with GV3 and with heavy duty, we have the option of running a track roller axes in parallel. That will provide far much more compliance over those longer lengths.
Yes, absolutely. And you're talking about longer lengths, and then we go back to the parameter of throughput.
Yes.
Okay. And to maximize your throughput on a long run, you really need high speed.
You do, yeah.
And in those situations, if you're looking at particularly high speed applications, that again can sway which particular solution you would use in those situations.
Yeah, quite.
The V-Guide, for instance, is very capable of high linear speeds. I would say in excess of 8 meters per second is quite feasible. Whereas your recirculating ball guide technology is limited to about sort of 4 or 5 meters per second.
Okay.
And that's fundamentally because of the design of the guide, the way the balls are recirculating within that block. You've got a long run and then it has to do a U-turn. So there's a lot of dynamics. It's suddenly reversing direction. Whereas with a V-Guide system, the bearing is circular and you've got uniform acceleration throughout the bearing race.
Absolutely. So it's in driving terms, it's a sharp corner, or it's a much milder corner. We've all driven around those bends, and we felt the centrifugal forces, and in that way the centrifugal forces on the V-type system within the wheel are much less than seen on a ball rail, and by that rationale, you can go faster. And like you say, we've gone very fast. Okay, so in terms of stroke and speed, that's obviously good news. For those longer strokes, let's touch more on the installation considerations in terms of having to button many tracks together. Again, this is something where the V system is very much suited, and even though you can do it with different types of technology, it's going to take more time and more cost to achieve the alignment that you need to get things working properly, and to not catastrophically fail if there's misalignment in the system that causes wear. Yeah,
absolutely. And the V-Guide system, because of its nature, it does mate particularly well in terms of the joint.
Yes.
You get good joint quality, which means as the bearing runs over the joint, it's almost seamless. So it's very easy to make unlimited lengths. The other thing you've got to consider when you've got particularly long lengths is your maintenance requirements.
Right.
Generally mechanical elements need to be lubricated. And that goes without saying, linear guides in general, they need to be lubricated. There are some instances where you can run these systems dry, but we would only really recommend that in sort of very low duty type niche applications, I would suggest. So if you're traveling a long length, you've got to consider how that lubrication is used. V-Guide is low requirements in terms of lubrication. The V-Guide spreads it thinly along the entire length, and it's only using the lubricant within the sort of contained lubrication devices.
Yes.
Whereas conversely, the recirculating ball guide systems, the grease contained within the block not only has to lubricate the bearing race itself, but also apply it to the running surfaces.
Yeah,
so it's sort of doing two jobs, if you like.
Okay.
And therefore you would need to relubricate on a more regular interval.
Okay, let's turn this round, and we've talked about really long lengths of travel, and we know that the V system is suited to any length of travel really, but let's turn it right around and let's talk about applications with a very short travel, maybe just, I don't know, 10 millimeters or 15 millimeters, and this is something that's happening, indexing back and forward maybe 3 times a second. What direction would you be looking at in those sort of instances, Alec?
Yeah, well, it comes back down to that lubrication again, really, to a degree, David, and the fact that, you know, those sort of very short strokes with a V-guide solution, you're not effectively getting a chance to fully distribute the lubrication, because you're not doing a full revolution of the bearing. So you'd almost have to treat that as a dry running application.
Yeah.
Whereas the ball rail block, it contains the grease within the block, and therefore would be slightly better in that situation, I would suggest.
Yeah, I think you're right. I think so. If you're talking about a very short stroke, you're talking about a lot of action on a small piece of slide. And in the wrong instances, in terms of lubrication, that can lead to an accelerated wear in that sort of period. And as a general rule, we like to see like you said, we like to see our wheel do at least a full rotation. And so there are these nuanced applications where a small ball rail could be better suited. And again, we've got the benefit of being able to specify correctly every time. Can we get on to environment? It's a big subject, and it's a very important subject. And let's kick it off by going through some of the environments that can apply to the different types of products that we have.
Yeah, so there's a few situations we see more commonly. There's sort of the wet, damp, moist, humid environments, which, you know, if you've got a carbon steel guide system, they don't like it. They essentially rust. So either you need to protect that carbon steel system with a coating, which we can do. You know, both the V system, we can offer a TDC coating, and our ball rail system, we can actually offer a radent corrosion resistant coating. But probably the most effective solution is to go for the stainless steel materials. And, you know, I'm pleased to say that we have a lot of options in that respect, don't we, David?
It's almost a standard option in most of our ranges where we've got those stainless steel options. And quite frankly, I think that's why one of the reasons that we do so well in food, packaging, those sort of environments that maybe see washdowns or wipe downs, and carbon steel linear elements, you know, would be a limiting factor, and as I said, that's why we do well.
Yeah, and then you know, the other environment that we see quite often is dirty, you know, dirty, dusty processes. You know, whether it's sort of, you know, we've done slate cutting applications. I've seen applications in concrete factories, metal cutting, and you know, that can be particularly onerous on a system. I would say really, you know, the recirculating technologies suffer the worst in those situations, because if you get any dirt or debris within those, you're effectively looking at game over. You know, the thing will basically eat itself.
Again, catastrophic failure. If it gets past that sill and it's within the, you're absolutely right. Yeah, it's a bit of a no-no. Yeah.
And then on the flip side, you've got the sort of V-guide systems, or even a plain bearing solution. But in particular, the V-guide solution is sort of self-cleaning, so it works. And we've you know, talked about the merits of that system many times over.
And I'm sure we've all been involved where we've replaced a recirculating ball technology with a V system in situations where the recirculating technology was failing, and failing quickly because of the hostile environment. And like you say, with the V system, the bearing balls themselves are encapsulated and greased for life. And on the V-track itself, the science, we've got this natural wiping action that expels dirt and debris away from the process as it goes. And yeah, we've got many case histories and stories that we can share where that's absolutely been a real success in what the customer's been trying to achieve. How about extremities of environment other than dirt and dust, Alec?
Yeah, so there's obviously, you've got heat, you've got cold, you've got possibly vacuum environments for scientific applications, and again, our V systems, we do offer solutions within that, but again, very sort of niche outlying applications in that situation.
So what we do, we have our stainless steel range, or ranges, and within that we have a certain number of bearing types where the grease and the internal parts of the bearing, such as the cage, are different and suited to that high temperature, that low temperature, or specific vacuum environments up to a certain level of torque. And again, I think we've probably got both got experiences where that opens up applications to us that would otherwise be not possible, sort of like within our range, and most likely other ranges out there. So yeah, it's a defining attribute of ours that we do have those various options. So suited to so many different environments.
Yeah, definitely. And I think we're now sort of getting to sort of looking at the sort of small details of the applications, and to sort of close off, I guess, this session, we've got to look at the budget requirements for a particular installation, and you have to consider what type of guide do you need for your particular application. If it's low precision, do you need a fully ground slide? And if you're moving cookies from point A to point B, you don't need sub-millimeter accuracy. So really, that's another decider. Could you use something like a shaft with a ball bushing on a simple vertical motion? Yes.
Or an unground V-slide.
Yeah.
And obviously within our range of V-slides, we have various grades of precision. Alec, we could talk about this all day.
Yeah.
And there's so many things we haven't covered, but we've promised our viewing audience that it would be 30 minutes, and that's what we're going to do. Let's finish with one thing. It's a sort of like almost a given, a fundamental when it comes to design, and that's, does it look right? The system that you've got, that you come up with, needs to look fit for purpose, and the designer needs to have a comfort factor within that. Yeah, so the size of the bearing, the size of the rail, in terms of what it's moving, the work it's doing, needs to be correct.
Yeah, absolutely. It's yeah. You look at any sort of job, and I've seen it many times. You see an application. Generally, if it looks right, it is right. It works. So yeah, and then I guess to really conclude, all of these discussions, you're not on your own with these decisions. You can speak to us, and we can assist you with this whole process. And if you need component parts, because that gives you flexibility in design, that's great. But also we have a lot of system solutions as well we can offer. So modular units, and we can do fully designed systems as well.
Ideal. Yeah. Thank you for listening.
Yeah. So thank you for that, and I think we'll open up to your questions now. So thank you very much for your time today, and this is the point where really we hand over to you and invite your questions. So please do drop them into the Q&A module, which is at the bottom of your screen. And David and I, as ever, will do our very best to answer your questions. So yeah, we welcome your participation. And David, we'll launch straight into the first question. It sounds like an application question here. So I have a payload of 250 kilograms, which I need to move back and forth 8 meters horizontally should I be looking at GB3 or HDS2?
Good question. I think the first thing to look at there is we are looking at what we would describe as a long stroke. So in terms of matching and butting V rails together, I think the V system is absolutely the right choice, because that's where we excel when we're butting rails together. The compliance available in the V system is ideal. The other thing to consider, of course, is, did you say 250 kilos?
250,
so what does that look like? What's the size of that? What's the physical size of that? Where is if for instance we say that's maybe a meter cube, then we might assume that the center of mass is maybe half of that, 500 millimeters above the line of the V, and that will or could dictate what type of system is used, depending on the speed and more importantly the accelerations of the system. Where a moment load applies through those acceleration phases. The other thing to consider is how you're driving it. You know, is this the 8 meters pretty much excludes a screw drive. So we're probably looking at a belt drive or a rack drive, or of course linear motors. But in terms of a rack drive, for instance, where this is one where we could be looking at GB3 or heavy duty. But in the heavy duty range, the rack, the sizes of mod go up to a mod 5. And obviously with that, you get greater drive forces. And it could be one of those situations where it's the driving format and what you require in terms of speed and acceleration that dictate whether it's heavy duty or whether it's GB3. If accelerations and speeds are lower, then the designer has more choice as to what personal preference to some extent.
Yeah, and I guess, really, I'd just like to chip in and go back to the point we discussed earlier about having, the difference between a single rail solution and a twin rail solution.
Good point.
Potentially, I guess with 250 kilograms, we could sit that on a heavy duty double-edged slide, and you've got a single rail and don't have to then worry about the complications of setting up 2 rails in parallel.
That's a good point. Again, it depends on the size of that physical payload. And of course, within the heavy duty range, we talk about driving it. You could drive it with an HDLS belt driven module with track rollers in parallel to provide all the compliance that you need, and a wide envelope to sit, which is probably, unless it's lead or uranium, it's probably a decent size. And the larger the size, the more you're looking at 2 rails in parallel. But yeah, good question to start with.
Yeah, absolutely. Okay, next question. Right. I would like to exchange a guide system from one manufacturer to a Hepco solution. Is there an overview of what is compatible with Bosch, THK, HIWIN, and etc.?
If I go first, I mean, obviously, in terms of that type of bore rail technology, they are more or less to international DIN standards, aren't they? So the HLG range, the HepcoMotion HLG range will normally be directly compatible with those products. Worth mentioning that you can't take a runner block from one and put it onto a rail from another one.
Yeah,
and you are absolutely replacing the complete system. If you're looking to move from that type of technology, maybe due to a problem or something different, then and you're looking to achieve the same envelope, then essentially the V system is, well, it's a different animal, Alec, and you need to consider, you need to speak to us about, the sizing that you actually require.
Yeah, so just to finish on that one, I would just say, please check out our HLG range. All the details are on our website, CAD models, etc. And you'll be well away. Next question, I'll pick this one up straight away. What is the level of gear accuracy? Are there any gaps in the gear? Okay, so with a rack and pinion drive, one of the fundamental things that you need is a degree of clearance between the pinion and the rack. and typically we would set that at between 0.1 and 0.2 of a millimeter. All of our rack-driven solutions use an adjustable feature that allows you to position the pinion in the correct mesh with the rack to get that correct clearance. So that is the type of clearance you need. In terms of rack accuracy, then it's typically about, or rack deviation, shall we say, about 0.1 of a millimeter every 300 millimeters.
Yeah. I guess that relates in some point to backlash, and that clearance will manifest itself as backlash. So in traditional terms, you take the backlash out, and then when you're driving in the right direction, that's removed.
Yes, and obviously if backlash is an issue for your application, you can look at other drive solutions. You know, if you went for say a ball screw solution, that is zero backlash, and it will give you the ultimate sort of linear accuracy and repeatability.
I think it's worth pointing out that also our belt-driven modules are zero backlash. So again, if backlash is an issue, you are not limited to one type of drive technology.
Okay, right. Move on to the next. Some great questions coming in. Thank you. So keep them coming, and we'll keep going as long as we can. So next one is what is the best linear technology for a clean room environment?
Fancy it?
Yeah. Okay. So the clean room environment. Now there are many different levels of clean room, as we know, and at its dirtiest end of the clean room, the restrictions aren't particularly onerous, and you can in general use a fairly standard linear guide system, as long as you are adequately removing particulates from the room. So if you've got a vacuum system that's underneath your linear guide system on a sort of class 9 clean room, then that is suitable. But when you start getting up to the higher levels of clean room, then there are a couple of options that we can also offer. Within our stainless steel SL2 range, we have sort of vacuum grade bearings, which can be suitable. We can also, because we manufacture our own bearings, we can actually fill bearings with specialized greases. So this could be a vacuum grade grease, even to your specification. And indeed, even some of our linear actuator modules, the SBD actually has a clean room variant. So it's a sealed belt drive, and it has extraction ports within the module, so you can actually take the air out of the unit. You're sort of drawing air in from the environment, and it makes a sort of a ready to go solution in that respect.
I think you've explained it all very well, Alec. We are no strangers to clean room applications. It somewhat depends, like Alec said, on the classification of the clean room, and customers will usually consider what they need to do with our systems over and beyond the SBD that you talked about, where the extractor, the vacuum ports are facilitated into the module. Customers will normally, you talked about vacuum scenarios to draw away any particulates. Customers are generally accepting that's what they need to do in a clean room situation, where they need to use our RV technology.
Absolutely. Okay, on to the next question. In many of the cases we've discussed today, the V system seems to be preferred. Yeah, absolutely, and we sort of said it's got the widest field of viability, and we certainly see that with the majority of our applications. But what you're asking, what are the unique advantages of a recirculating ball system? So there are some, and I'll touch on some of these. Obviously, with a recirculating ball system, you've got quite a compact solution there. So the footprint of one of these recirculating ball guides is comparatively smaller for its low capacity. It's also very rigid and very stiff. But of course, you've got the other factors to consider, such as your installation and mounting, and various other environmental factors that can affect it. But yeah, certainly it does have advantages. Other ones I can think of, they're very good at high accelerations, although the overall speed is lower.
Yes.
Um,
And we touched on the extremely short high
stroke
frequency strokes.
and I would say if you've got a sort of high vibration or impact loads, then because of the larger surface contact that a ball rail solution gives you, it would be better in that particular situation.
That's a good point. Typically with a V system, you have 4 points of contact on each of the 4 wheels. And with a ball rail, of course, you have an array of balls that will be sharing that impact. Vibration and shock forces, of course, are not friends to linear technology. And there are other types of linear technology where those sort of shock forces are even better dampened, shall we say, with a dry line or with a Pacific type technology. But yeah, good question.
Yeah, absolutely. Next one from Barry. Thank you, Barry. Is the HLG range available in stainless steel? So Barry, we have within HLG is the MLG range, miniature linear guides. They go up to a size 20 rail and they are available in stainless steel as standard.
Yeah.
Okay, next one. We have a project for a cheese filling machine. The filling unit will move vertically. The travel distance is 300 millimeters. Payload is 28 kilograms. We want to use round bars with lubrication and maintenance-free bearings. What is your opinion?
Well, this is food, and it could well be that lubrication is no problem if it's kept away from the product, kept away from the process. Or it could well be that this is a situation where you need to be looking at a stainless steel solution and potentially even running dry. It's difficult to be more definitive without knowing more about the application. Round bars can and are typically used, that type of round bar technology, but you'll forgive me if I draw you back to the V system and how it might be very well suited to also include any offset. It's a vertical application, so you're having to deal with gravity as well. When you're driving the system up and down, you're overcoming gravity as well as frictional forces. So yeah, please give us those details. Not knowing who that's coming from.
I think just to add to that question, and David's excellent answer is that we would suggest that, you know, if it is a vertical application and your payload is offset from the central axis of that plane rail system, then you have to be very, you can use a plain bearing solution, but you have to be very careful about the offset loads that creates, because all that, exactly, you've got to have the a correct ratio between the bearings and the offset. Otherwise it sort of jams itself up. You know, you can get a excessive friction, you get heat build up. You also have to be very careful with your the alignment of the 2 rails as well.
It's a very good point. The 2-to-1 ratio, it will jam itself up, it will crab essentially after that point. But my experience is that anything where you're using that type of technology with an offset could create a problem in terms of heat and wear and accelerated wear, and that type of technology for me is better suited to direct loads only.
Great. Okay, next question. Is the gear accuracy all the same for GV3, PRT2 and HDS series? So yeah, essentially the process we use to manufacture those racks is the same process, so therefore the accuracy is the same across the range. Okay, please do keep those questions coming. Like I say, we'll be here as long as you need us. Next question, David. How does orientation of the system affect selection?
Well, it's our old friend gravity again, Alec. Where you have a scenario, let's just say, let's go back to that first question about with a 250 kilogram payload. That in a horizontal, it was horizontal, wasn't it? It was 8 meters of horizontal
that's
travel
what we
from
talked about
memory.
first of all.
That's relatively easy to push, bearing in mind the incredibly low coefficient of friction of our linear systems. You change that to a vertical situation, and you're immediately then trying to push 250 kilograms up against gravity. So the drive capability has to be much higher. You've also got vertical, you've got railway tracks horizontal, you've got railway tracks where you move them vertically and it looks like an equal sign, where to all intents and purposes it's still the movement is still horizontal, but all of a sudden you've got vertical forces imposing most likely outboard of the track, and then you've got the truly vertical rails where you will probably still have that offset, and you're having to drive it vertically. And I think what we're normally talking about is, as soon as you are looking at having to deal with gravity in respect of an offset or driving, then you are most likely going to be looking at heavy duty rather than GV3 in that specific application.
Yeah, thanks, David. Okay, next question. We've got, what linear guide would you recommend for a washdown application? So first of all, I would say it almost certainly has to be stainless steel. And as we touched on, fortunately, most of our product ranges are available in stainless steel as standard. But you also have to look at the degree of the washdown. Is the jet being directed directly at the linear guide system, or is it indirect?
The pressure,
the type of the chemicals that are being used. Now, because we use a 400 grade stainless steel, which is highly polished, it does still have some carbon content. So for particularly aggressive chemicals, high concentrations of caustic soda may not be suitable. But that said, if you've got a freshwater rinse that is taking place, then sort of our SL2 range is suitable. We also have the dual V range, which has specific washdown wheels as well. So yeah, certainly a lot of our stainless steel ranges are suitable, and that includes rings as well, doesn't it, David?
It certainly does, and we've always excelled in food processing and food packaging applications where washdowns and wipe downs do apply. So we're no strangers to that. I think Alec essentially hit the nail on the head. We need to know the mode of washdown and the finer details of what's actually happening, the distance, and where it's being applied. And yeah, we can normally come up with the right solution to suit that particular requirement.
Great, thanks, David. Okay, I think we'll take maybe one or two more questions. Next one, you've talked about different types of mechanical guides, but what about drive solutions? What drive solutions would you use in these instances?
So this is
a massive question in itself, and we could probably do another webinar on it.
I think we should,
in its totality. But yeah, you've got to consider, based on your application, how are you going to drive it? Now, we talked about high-speed applications, and for those type of instances, you might want to consider a sort of a timing belt drive. It will give you very sort of high speed, certainly capable of up to sort of 8 or 10 meters per second. But then you have got length restrictions on those, David. Whereas a rack drive in comparison, you could go on forever. But again, you don't get the same sort of speed performance from a rack as you do a belt. So that's a close run thing. Then I guess we have to mention screw drives as well. They are very much more limited in terms of their overall length. Sort of about 3 meters is about the limit you'd want to do with a screw drive, because you are limited by the speed. The faster you spin a screw, you've got what we call a critical whirling speed.
Buckling forces.
So, you are limited. The longer the screw gets, the slower it goes. Obviously, you can have different pitches, different leads, which will allow you to accommodate different speeds. But on the plus side, you've got greater accuracy and repeatability, particularly if it's a ball screw solution.
Quite so.
One of the other things I guess we should absolutely touch on, because it's been one of the latest game changers in terms of technology, is linear motors and linear drive technology. And of course, you know, David, we've recently, you know, or not recently, the last 8 years, been working very closely with Beckhoff and their groundbreaking XTS system. So, you know, that's just a key example of you know, one of the sort of latest cutting edge technologies that we're involved in.
Absolutely correct. Yeah.
Okay, I think we're just about at the end there. So I would like to finish off by thanking you all very much for coming along today. Thank you, David, once again for being my wingman, and very much thank you for all your questions. We hope to see you again very soon. We'll be certainly doing more of these. Keep an eye out on our LinkedIn and our website for all the latest news and updates.